Oh, hello.
Hello. What up, upper dudes?
After our incredibly successful first video, we got lots of comments and replies asking how the hell are we having so much fun doing this, and they expected that we were using half-legal substances. I don't know, is it legal now? I don't think so.
No, not here.
No. Yeah, but
we wouldn't know about it.
Of course not. And we have to disappoint you. We are just funny by nature, I guess.
So,
that
what
wasn't
happened?
a very funny introduction.
No.
I think we have to up our game a little bit during the video.
We'll see how that works out. Well, let's start.
Okay.
What happened between the last team talk and now, Sebastian?
This team talk we will answer less questions because we answered them already
Yes.
in
No
the
more
last
questions.
video. And we'll just talk about what happened and what's going to happen and insights into several topics of the project and that kind of things. And the first topic that we prepared is we want to give more insight into the hardware and software development process. At least that's what somebody wrote in this document. No idea what we should talk about now, but I'll just read it out loud. Now, last video we explained that we kind of focus first on the hardware and then on the software.
But is it true?
Nah, it's not entirely true. That's why we should revisit that again, because it's pretty much an iterative process and a lot of things happen in parallel. So of course, first we have to work on the hardware, and until the hardware is finished we can't do much in software. But once we have the basic hardware complete and operational, we will start with software, but then the transition to software and then back to hardware and improvements there and here and there.
That makes sense.
Yeah, it's kind of a smooth transition, and at some point when the hardware should be finished, the software will take the majority of the focus and efforts. But yeah, and as I said, it's an iterative process, so all components and all modules are prone to improvements over time.
So there will be many versions then.
Yeah, there will be several revisions, and also the very first finished hardware that will be like the baby beta will be a different child than when it's all grown up. So the first backers will receive another hardware than the backers that will receive the last batch of cameras, basically.
What about the adolescent puberty version?
We'll have more about the hair, the shaving options later. I saw somewhere in the video, or in the documents.
Yes.
But so, you as backers have the responsibility to decide when the camera is mature enough that you want to get involved. We will try to make it as clear as possible what the current hardware revision is capable of and what it's not doing yet.
And the more out of the box you want it, it would be better to purchase it later out of the later batches.
But if you're a developer and want to get your hands dirty early on,
in the infant stage,
want to get the first revision, a very early revision. But what we always want to offer, we will offer, is that if you have first revision camera and want to upgrade the hardware or certain boards to a later version, you will be able to do so at cost for all crowdfunding voucher holders, of course. Yeah. Okay, the next point is we already covered partly in the last video that we had delays over Christmas and delays with components and delays with shipping, and we still have a bit of delays here and there. So it currently doesn't look like the first batch will be really finished in April.
Well,
yeah,
it's not really our fault, to be honest.
But we could have been faster. I guess. That's how it is.
But don't tell that to anybody.
We share, in all our honesty, it will be delayed, and we will, of course, keep you updated about what's happening and if there are other delays or if we are faster.
But the more Team Talk videos we make, the longer it will take to finish the camera. So we might have to fine-tune the frequency.
I can do it alone. Can you create a camera in the meantime now?
Okay. Yeah. Done.
Very good.
Yes.
Delay cancelled. Yeah. Maybe we should explain a bit more about what caused the delays or what kind of postponed some of the decisions or the hardware components. So as we talked about, there are some component delays and some delays with tools that we require, like the CNC mill, which we will cover later, I think. There have also been a lot of changes, additions, and new features that we implemented, as we discussed with community members and people from the crowdfunding campaign and team internally. And what we got was that we had to change, or we decided to change some of the hardware elements or some of the underlying architecture that makes the camera a bit more powerful and a bit, it's a few new features.
Versatile.
And that, of course, caused us that we had to redo some revisions of the hardware and design new interfaces or change the PCB stack a little bit, as we already showed last time. We will show it again now. And last time I think we explained that the beta is not yet that modular as, for example, the gamma will be. But now with the planned changes and the new additions, the beta will already be a lot more modular than before and almost as modular as the gamma.
Which doesn't exist yet.
Yeah, but the plan is more modular,
Yes.
more flexibility.
Great.
Yeah. So let's do a little rundown, maybe a bit technical, but that's also part of the team talk, I guess. The old concept of the beta was that we had two shields, which are kind of add-on modules, but we call them shields because that's what Arduino people are familiar with. And we had one low-speed shield and one high-speed shield. Now, with the changes to the architecture and the PCB stack, we have two medium-speed shields, namely with around 200 megabits per second to the one shield and 1 gigabit per second of data to the other shield. So that's much faster than the original slow shield and medium speed shield. And we have something new that's not called shields anymore because it's more of an extension card or extension module. So we have shields now and we have modules. 2 shields, 2 modules, and the modules will also have 2 slots. They can be hot plugged, so it's like a PCI Express card in the PC you're building.
Which cannot be hot plugged.
That's true, so it's even better than
Even
PCI
better,
Express.
yes.
It's actually not PCI Express, it just uses the PCI Express connector, because that's something that's readily available and has a lot
I
of...
can't mount my new graphics card then?
Mount maybe, but...
What a pity.
Then. So it uses the PCI Express connector, but it's not the PCI Express protocol. It's our own protocol, or communication line. And so we have 2 PCI Express slots, and we have modules that mount to 1 slot. So you have space for 2 of them, or there are modules that occupy 2 slots. And one PCI Express slot has a total bandwidth of around 6.2 gigabits per second. And if you combine both slots in a double height module, you already have 12.4 gigabits per second throughput bandwidth. So that's a lot
Of speed.
and data.
And data.
More than USB-C with only 10 gigabit.
It's incredibly fast. I'm almost drowning myself here because it's faster than Thunderbolt, faster than USB 3, I think, faster than 10 gigabit Ethernet,
Faster than USB-C.
and USB-C,
Holy shit.
whatever that is.
I don't know. But I bet it's hot pluggable.
Probably.
Yes.
Yeah. So that's the new modular concept. And now it gets even more technical, I'm afraid. The idea is to use 2 additional small FPGAs on the main beta board. And why do we do it? It's to being able to route the data in a flexible way. because as hardware is hardwired. Very good. You follow me?
Yes.
The way you design the hardware is the way it will stay forever. And the FPGA is already a kind of transition into a more flexible software-defined hardware. But it still means that the PCB and where the data is coming from and where it is going is fixed, and you can't do anything about it unless it's going into the FPGA and you can decide what to do there. But there are other components as well on the PCB, and they don't have any way of getting that data if they want to. So the idea is that we use additional small FPGAs that are entirely designed for routing the data of, for example, what's coming from the shields. That can be external sensors like an IMU, for example, or the general purpose input-output ports and the FPGA. And yeah, you can, like a network of cross sections, design where the data is coming from and where it is going, and if you want to process it in the FPGA or in the microcontroller that will be on one of the shields. And a bit more about it also later, because there are some very interesting features that this microcontroller can take care of. And yeah, that opens up a lot new possibilities regarding future add-ons. The use of certain data components and external interfaces that were not yet possible with the camera.
Sounds amazing.
Perfect. Then
Took my breath away.
think about, we can attach LCDs on the microcontroller, for example, or the 3D accelerometer and gyro and compass data, and we can decide if you want to route it through the FPGA or to the microcontroller. You have no idea what I'm saying, right?
Of course I do. You just
Perfect.
explained it perfectly.
Wonderful.
How can I not know?
Then I'll not explain it again. So, for example, for stabilization on drones, that's very interesting.
Yes.
Or yeah,
But will it be small enough to mount into a gyro stabilizer?
I guess it's pretty lightweight, since you can remove all the enclosure and all the heavy parts, all the metal, and only the electronics remain. You can build a new compact enclosure, and yeah, it should be perfectly fine for drone use.
Lots of people will love this.
I guess, yes. Then we have a new power board. The first version that we already received, I think, from PCB manufacturing had LDOs, which produce a fixed set of voltages. And the second revision will produce kind of programmable voltages.
Why would you need a program?
It's
for
of course a
voltage?
very strange word, because it doesn't have to do anything with programming. But you can choose the voltage ranges or the voltages it generates dynamically.
to power accessories.
For example, or a sensor that we didn't think of yet, which requires a certain set of voltages. And this new power board will, out of the box, be able to do that if you just program the voltages to the ones matching your requirements.
But you have to change the sensor board then.
The sensor board will, of course, have to be a new one if it hosts the sensor, yes. Also, the new image sensor interface board, because you have to replace the sensor board when you add a new image sensor. But this image sensor board doesn't have to take care of all the things that happen with the image processing before it enters the FPGA, because we have an additional image sensor interface board. And the first version that we created of this image sensor interface board does hardwired reduction of the total I/O lines from the CMV 12000, which means that we can only use half of the lanes, which reduces the maximum throughput from the sensor to 150 frames per second in 4K, which is still more than we can actually deliver on any output. But the second generation, the next version of this board, will implement another FPGA in the image processing or pre-processing pipeline, and that will act as a serializer, deserializer, and push more data in the same amount of lanes by increasing the frequency, basically. And that way we will be able to go up to the full 300 frames per second in 4K that the CME 12000 can provide. We still have to figure out where to store the data or how to output it, because all the other interfaces are too slow. But at least getting the data into the camera is solved. One step at a time.
One step at a time.
And most of these PCBs are now redesigned. It also took some time, of course, and are already ordered from our PCB manufacturing partner and on the way or have arrived already and being assembled. And that manufacturing partner is also our next topic that we want to cover, because it's the open source hardware park. And as we are doing open source, that's of course something that we should explain in more detail.
Yes.
The idea is, or let's explain the problem first maybe. If you order printed circuit boards in low volumes, it's always very expensive. Because basically all the facilities that produce PCBs produce fixed size panels of PCBs. And if you want 100 units, that's basically costing the same amount as if you just want 1 unit, because it fills up the entire panel just for you, and you have to pay several €100 or even more for the entire panel, even if you just want a tiny board for your own. Okay, so there are services that pool together orders and just distribute the tiny boards from everyone on the panel, and that way the cost of the panel is divided on all the people that participated in the panel, depending on the area that you used on the panel. And that makes it much, much cheaper. Instead of a few €100, your small printed circuit board suddenly costs you like $5 or $10.
It's very convenient.
Yeah. And one particular service provider who does that is Open Source Hardware Park in the United States. Maybe you've seen the typically violet printed circuit boards that we have in all our prototypes. That's coming from Open Source Hardware Park, because they have this distinct color they're using for the materials. Yeah, and another very interesting thing about the Open Source Hardware Park is that you can upload your designs and share them on the website. So you can download our designs there, and you can even order your PCBs directly from them, which is again very interesting for open source hardware, I guess, because they are so affordable, and you can get the parts directly from this external service provider. And yeah, that's also because they are limited to 2-layer and 4-layer PCBs. Normally, if you do a complex hardware, you can easily get into the range of 6 layers, 8 layers, or even more. And that's something that's becoming a bit tricky to pool together, because there aren't that many people that do 8-layer boards as hobbyists or as hacker projects. And so the maximum number of layers they do is 4 layers. So for us, that means the design is getting a bit more tricky, because we have to fit all the complex routing and all the dense component structures into 4 layers. But we are willing to do that just so that we can go to Open Source Hardware Park, and that you can order your or our designs and your copies of that hardware. That's the idea
great.
of the beta. In addition to making sure that the designs can be ordered from there, we also try to use only components like connectors or whatever electronic parts we need that are widely available. So again, when you order it from Open Source Hardware Park, that you can also source the components easily and build your own copies of our camera.
It's very economical.
Yes.
Wie viel bekommt jetzt von denen für die Werbung?
Nothing.
We don't get any money.
We should ask for a
Product
discount maybe. But they're already so cheap, so...
I thought you prepared your product placement because it was so straightforward.
It's
Even
just
mentioned the distinct
an
color.
honest review, I guess. But let's see, Open Source Hardware Park, maybe we can talk about an additional discount or something.
Yes, contact us at team@apatools.org.
we received an email from a very concerned community member, and he wrote, I quote, "I really enjoyed your team talk, but I'm concerned about health and safety. Many of the early adopters and designers, it seems, are statistically more likely to sport hipster beards."
Why are you looking at me?
No, I'm just telling you. Hipster beards. And or ponytails. Which, in view of the open access fan on top of the beta prototype, could pose a very real risk of hair fouling and possibly camera malfunction, not to mention personal injury. Have you considered this? Would you be liable for injuries sustained as a result of fan hair incidents?
We already apologized for Sebastian's pathetic attempt at a beard last week. But who asked this?
I don't know, but we take this, of course, very seriously, considering we have no idea who would see people like this using the camera.
No. Especially because we designed it in a way, it just trims your hair. Maybe.
Exactly, we have the perfect solution already. And we will simply tackle that problem by officially selling the beta as electric beard trimmer.
Yes, of course. That's what we always intended.
The only thing we have to change are
razor blades.
Fans, razor blades, exactly.
Very safe.
And
children, babies, dogs.
Maybe we have a prototype to test already next week. Maybe you can be a beta tester.
Is that because I get beaten if I don't test it?
No, just the beer will. Maybe we can, it's a perfect synergy of what you need and what we have.
Yeah. Why would I need it? Why does everybody hate my beard?
No, I never said that. It's
but you want to get rid of it, it seems. You designed the beta to shave my particular beard.
Let's see if it actually works. Let's see. Maybe you can.
Is the trimmer then also in beta stage, or is it still in alpha?
We'll see about that and how your face looks then.
Are the razor blades open source?
I don't know about that, but they are definitely very sharp. Maybe we're getting a bit distracted. We wanted to talk about the microcontroller on one of the shields. And that will be a PIC 32-bit microcontroller. And this microcontroller will control everything general purpose I/O related and power-wise related to the operation of the entire camera. And that means that this microcontroller will be able to power down the image sensor, the FPGA, and the rest of the camera, which means the operation will allow extremely low power standby mode with power consumption of the entire camera below that of a single LED. Now you will ask me, I guess, why would I need a camera that,
that only uses so few power?
So little power like an LED. For example, if you make time-lapse recordings, you could program the microcontroller in a way that it powers down the camera, waits for, I don't know, half an hour, or how often you want to take a picture, wakes up the entire camera again, snaps one picture, saves it to a card, and puts everything into sleep mode again. And that means you can operate this time-lapse on battery over several days and still get high-resolution raw images from exactly the time periods you set. But it will hardly drain any power during that time. That
sounds great.
One of the many possible ideas that you can do with that. Or you can connect external sensors, for example, and let the camera react to whatever sensors you think are interesting for your application, and that way, yeah. But it's definitely an interesting feature and will open up many new possibilities that the community will come up with, I guess. guess.
It will be the most economical beard trimmer ever made.
You can power it down until the beard has grown up to perfect length again and still use the remaining power left in the battery pack. Yes.
Great. Shall we now come to the part where we talk about all our new stuff we purchased?
Yes.
Again.
We didn't purchase anything again. We just purchased
New
more stuff.
Again.
Like a high performance oscilloscope, which is already in full usage for testing and debugging. And I made a video of it, which we will show now, I guess.
Great. Shall we wait?
But we also purchased a heat sensing infrared camera.
Yes, for your new iPhone.
Which I purchased just for that, because I wouldn't ever use an iPhone for... hello? Yeah? It's the FLIR 1 accessory for the iPhone 5, which does low resolution heat sensing video and images. And why do we need that? For evaluating heat dissipation and the cooling concepts in the beta, because you can see inside the enclosure and measure temperatures pretty accurately. Yeah, and we also have some sample footage here, I guess.
Yes.
From the AXIOM beta prototype heat dissipation of the components.
Yes.
And what else did we purchase?
We can't blame it. No. It's a camera.
No, it's a mill.
Oh, it's the mill. Yes.
The mill. The CNC mill, which we introduced last Team Talk, has finally made the journey across the ocean.
Crisscross.
Which has taken 1.5 months just for shipping it to Europe. But
it survived.
It's survived. It's a very happy mill, and yeah, that's how we unloaded and brought it into the basement.
Where it will now stay for some time.
Yes.
Yeah.
Austrian basement.
That is fundamentally the situation. Right.
We'll make more basement jokes when we
show the video.
Show the mill,
yes.
And how we brought it into the basement.
Plays a very important role in Austria for everybody. So, what else did we purchase?
We have another story to share.
Yes.
We recently, because we want to document certain aspects of the project, like how the mill arrived and how we use the oscilloscope or how we assemble prototype components. And so we bought a very compact, pocket-sized, very cheap cinema camera. From a competitor, which we will, of course, not name here.
I heard they are the market leader for filming church masses and stuff. So they must...
Church services.
Yes,
yeah.
and they must have a very fitting name then, I suppose.
Very magic name, and that was very convincing for us. So we bought a second-hand camera, because we believe in kind of recycling, and the guy didn't need it anymore, so... We paid very little money, because how can we justify buying a camera if we have cameras all over the place soon?
But why was the price so low, Sebastian?
Tight negotiations, I guess.
Yes. And
yeah, and until our cameras are operational, we have to use something else. But that's not the entire story. The entire story is that we received the camera and we already knew that there were dead pixels somewhere in the image, which didn't alarm us at all because we know that all image sensors, when they are manufactured, have dead pixels. There's hardly any perfect image sensors because just the way they are manufactured will always have tiny defects somewhere. The manufacturer specifications have a certain limit of, I don't know, not more than 100 dead pixels on the sensor, then it's a good one, basically. So every camera that you used, probably every film that you have ever seen on television in cinemas, had a dead pixel somewhere.
Even if it was a digital sensor.
Yes, of course. And so we went and alarmed and thought, yeah, why not? They can be filtered out easily because all the cameras compensate the dead pixels by just replacing the data with neighboring values. And that's has been this way for several decades already. So, but we wanted to know how in this particular camera we can add this new white dot that appeared in the image to the list of pixels to be compensated.
Yes.
Because the firmware isn't open, of course. So what should we do? Is there some setting somewhere? Or do we have to download some software?
Or some magic, maybe?
Some magic powder? And so we wrote officially to the support of this camera company and asked them, there's a dead pixel, they wanted to see sample footages, I provided them the sample footages, yes, there's a white pixel, and they acknowledged the problem and said, yeah, it's a hardware defect, we should buy a new camera.
Did you buy a new camera then?
Of course not, I just bought a new second-hand one.
But how old are they?
I don't know, a couple of years maybe. So yeah, that was a strange discovery.
This
Modern technology has come a long way.
Yes.
If there is one dead pixel.
You're screwed. But this will never happen with the AXIOM camera.
Exactly, and that's why we want to share the story.
Yes.
Because with our AXIOM cameras, you will certainly never get such a reply from our tech support or from us when you ask us. They will just tell you...
Which will be us personally. Maybe not in the future.
We'll just explain to you where you can add the dead pixel to the list of pixels already being compensated. And then the camera will operate as if it was new, basically.
Wow.
Yeah. And now when
Sounds so easy, why can't everybody do that?
I don't know.
Money.
Maybe. So we thought about when we will use this camera, because we will not throw it away like suggested, but we'll actually shoot footage of what's happening in the project. I thought, should we kind of key out this single pixel and replace it? But now I'm thinking, why shouldn't we leave it in?
We should leave it in.
As a reminder of this story, and every time you see this footage, you will remember this won't happen with the AXIOM.
Signature.
Yeah. And as already explained in the last team talk, we will be at NAB this year.
Mm-hmm. Where exactly, Sebastian?
That is in Las Vegas.
Ah, yeah. Booth Las Vegas.
No, we already know where exactly we will be. It will be the Central Hall with booth number 8434.
Mm-hmm. I know exactly where that is.
Have you been there before?
No.
But yeah, since a lot of people who supported us in crowdfunding were from the United States, and I think a lot of people will be interested in our prototypes and maybe meeting us personally, even though they have seen our team talks still. Yeah, so
but we will bring all the available prototypes to show.
It's pretty soon, so
might be. Yeah,
we will bring something. No, but we would love to see you there. Booth C8434. And as explained last time, we were invited to NAB, or get a shared space in the booth of Dents, which is making cinema accessories, and are also a project partner in our AXIOM Gamma EU consortium. So perfect synergy.
Great.
Yeah, we got another Hugh Grant.
Yes.
Another
Huge Grant.
tiny Grant.
Tiny Grant.
Yeah, it's not a
It's a
big
cousin of Hugh Grant.
A small relative from Hugh is the small grant we got now compared to the EU grant we got. But even a small grant is a nice grant. And
Yes.
this particular grant, we will do development of, or we'll think about how we can share and publish 3D models that make up the beta. So that means the components in the beta
Yes.
as 3D models. What open formats are there to share them that you can reuse in different aspects, like when you want to make accessories or when you modify certain elements or want to build your own enclosure for the beta. So we will develop a way how we can publish all the components, all the drawings in the beta in a kind of component database where you have an interactive viewer, you can rotate around it and download certain drawing perspectives, that kind of thing. And we will also develop a kind of design corporate identity is maybe a bit too much, but a design layout framework for a manual for the beta that will target certain audiences. Like if you're a hacker, how to get started with hacking, electronics.
You can use it as a blueprint to make their own products or to describe
Exactly.
it, make a manual.
Or if you are just a filmmaker, which are the elements that are important for you, and give an easy to read visual overview. And yeah, for that we will kind of develop a framework, a guide, and a few example reference designs.
Mm-hmm.
Yeah. Then we have a so-called Ergonomics work group, which already met a couple of times.
Yes.
We have the documentation on the wiki, which covers all the individual meetings we had so far and what topics we discussed and what progress we made, and few aspects of the hardware redesign with the modules and the things we discussed earlier on were sourced from that ergonomics group.
Yes. It's a local group, so if
Yeah,
you
it's-
are not living around Vienna, it's hard for you. It might be hard.
We
for you
would
to
love
visit.
to share it over the internet, but when you want to touch certain things and discuss shapes, it's
Last time, for example, we discussed certain types of foam for the
for the enclosure
of the
packing
beta
formats.
and camera.
For example, there's a certain foam made from renewable resources, and
This is
yeah,
not so renewable.
not entirely, but it's the traditional foam. Or we have for the AXIOM remote created kind of
We
a
tested
race of buttons and small joysticks,
turny wheels.
and
We evaluated.
discuss how are you feeling when you press this button.
Yes. This one makes me feel very good.
How the force is and how the reaction, the tactile feedback and everything is.
All of the results are available at the wiki if you want to take a look or
Exactly.
even contribute something.
Yeah, we are doing now a new round of buttons because we weren't entirely satisfied with what we had so far. Because we care about the fun you have when you press the buttons and how you feel when this particular button is pressed. Or another aspect is that you don't want buttons on your camera to make a lot of noise. Like
Yeah.
this one is
This might
probably
be-
not a good idea. But this one, it's much more silent.
This one is the best, I think.
Yeah. Maybe let's try this one. Very good.
It gives me a good feeling. You want to try it?
Yeah, please. Ah, that's great. Yeah, or we had evaluate different metal surface finishes. I think it's in. There it is. And at first, we wanted to 3D print the very first enclosures of the AXIOM beta as plastic, as ABS and a 3D printer. And now concluded that we actually want a more solid enclosure also for the people that they want to use it in the field. And so with the mill that arrived and with solid aluminium manufacturing, we also looked at certain surface finishes or coatings. And what we looked at were powder coating, for example, which didn't have the greatest response because it feels a bit plasticky, even though it's metal. And then we have the classic anodizing of aluminium, which so far seems like the best option. And the colors, maybe we will think about that a bit more because this is the kind of natural anodizing format, but black works very well.
We still have to think about unique colors.
Unique colors as well.
Special backers.
Exactly. But currently it looks like the AXIOM beta enclosure will be aluminium. It will be anodized with black or neutral. And yeah, that's the main components of the camera.
That's a great choice.
Yeah. Okay.
Yeah.
So
thank you for watching.
that's it for now. And since so many people watch the first team talk and hopefully will also watch this team talk, we will hopefully do another team talk soon.
I saw not a single person dislike the first team talk.
Amazing.
Yes.
How did we do that? Don't dislike this video either, just because you wanna.
I think we'll cut this part out so nobody will dislike it now.
Yeah, that's true. Okay, so see you next time.
Yes.
With even more news and
More
updates
team and more
from
talk.
more
Or
team,
less talk.
more team, less talk. Goodbye.